Okay, this week we've got three different hazards we're going to talk about. We'll start with icing. Uh, a couple things I didn't know about icing. I didn't realize how much it affected power plants in an airplane. But icing is just a deposit of ice on some part of the airplane. And that could include inside the power plant, in the carburetor icing. And that's really due to the adiabatic expansion, or the cooling of the air below 0 Celsius. You think about it when the air is passing through there, it's changing pressure significantly so that it's winding up, as we know from that equation. If you change the pressure, you've either got to change the density of the air or your temperature of the air. And in this case, you're changing the temperature of the air to cool it. And it will really drop off significantly. You can even have icing even up to 80 degrees with really high dew points and have some serious icing. There are other forms of icing, obviously, icing on any parts of the aircraft. I've noticed it a few times when I fly out of Norfolk in the wintertime and there's a frost around that may not even be below freezing. It may only be 35, 36 degrees. But if you look out on the wings of the aircraft, you can actually see some ice particles and all there, and they'll come and deep ice the aircraft before we take off to make sure that there's no ice on any part of the aircraft. You can even, sometimes aircraft cool a little bit quicker maybe than the actual ground itself, so you may only have icing on the aircraft. If you think about it, there's just air around it, and that wing might be radiating really well, just like a car would or other metal objects. They kind of radiate pretty good, so it might cause some icing. We have no real direct reports of icing. We can observe it kind of in some model forecast and in some looking at soundings, but PIREPs are really a great source, so anytime anybody's flying, we love to see that. There are also some equipment now on aircraft where they take off and land, and it'll actually record the temperatures as they're rising or dropping down. And that information is passed on to the meteorologist now. And it really gives you a profile of what the temperatures are actually doing in real time. Some airports, like Dulles and stuff, literally have it every 5 minutes. It seems like there's an aircraft or landing or taking off, and I've seen some in the Midwest, some of the bigger ones. But even some of the littler ones, even Norfolk and Richmond have them a couple times a day and all. And they can really give a profile of the temperature real time, which really can help estimating how the models are wrong and how the icing's doing. Remember, the worst icing will typically occur with some kind of supercooled water droplet. And remember, when you're in a cloud, ice doesn't really form until it's like around -8, -10 degrees Celsius or colder. You'll start getting the ice pellets, ice crystals, and then icing takes over and changes everything over to ice. But sometimes from 0 to -10, that water is probably, cold. It's well below freezing. And so when it's sitting there like that and hits your aircraft, all of a sudden it has an object to adhere to, and it's going to wind up forming an ice coating on your aircraft. So it's just something to be aware of. The liquid water content sometimes in the clouds and stuff can really indicate, help with how many water droplets are forming, and how thick the icing might become very quickly. Remember, in a stratus cloud, you're getting fairly slow lifting up of the air. Typically, it's fairly stable, basically convergence and all pushing the air upwards, and you're going to have this layer of moisture there. Whereas you have much faster rising motion in a cumulus cloud, pushing that moisture aloft from the low levels. Typically, it'll be warmer and a more moist atmosphere as well. So you may have a little more icing in that kind of a situation. So if you're approaching like a cloud deck and a warm front, the clouds are slowly lower. More supercooled water is going to develop with time, and that warm front may have some instability as you approach it. So you have increasing pockets of supercooled water, and therefore you get more icing. Droplet size plays a role, obviously, when they gradually form raindrops, which can happen in the summertime, for example, without temperatures ever really going below freezing or no icing forming in the clouds. Sometimes you get even up to 12, 15,000 feet before you reach the freezing level, and maybe the cloud top's only at 20,000 feet. So you wind up with this area of icing, above the freezing level there, and it might even get below -7 or -8 by 20,000 feet. So you have a whole thick layer of moisture there that's freezing. Well, supercooled droplets, and with the collision coalescence process that occurs sometimes in these clouds where you have cumulus, lots of rising air in them, they're going to bump raindrops bumping together, and they just form bigger and bigger raindrops until they can finally fall. And those are all hitting your aircraft and all below freezing. So you're going to have issues with icing. A lot of times in winter storms, you can have icing as well. Uh, Particularly if you think about moving on the northeast side of the low where the warm front loft might be. And it's not a continuous layer. Oh, it went below freezing, so the rest of the way is going to be below freezing. No, sometimes in the atmosphere you go below freezing, then you'll go back above freezing for a portion, and then you'll go back below freezing, and you may even have 2 or 3 layers where you do this. And sometimes if you're a pilot, you might want to know that, because if you got to be flying one of those zones, you might want to pick the zone where it's above freezing so you don't have to deal with the icing if you can get away with it. I know air traffic controllers and all have a lot to say on what level you're flying at in these storms and these clouds and all, but it's just something to think about when you're planning a trip. And again, during when your occlusion phase, when you have the warm air is pushed aloft, uh, so you have snow above that warm layer that melts, comes down into the warm layer, and then there might be a cold layer below it. So if you're flying below that layer, you might have a super cold air mass in place, causing more icing. And on the east side of the Appalachians, and the same thing can occur in some out in the Rockies, but it's more predominant. It seems like more people talk about it anyways. Cold air damming on the east side of the Appalachian Mountains, all the way down from New England to even down as far as Atlanta. You get this cold dome of high pressure to the east of the mountains, traps in this low level air of cold, very cold air. That cold air can be anywhere from 1,000 to up to 4,000 to 5,000 feet thick. So if you're taking off, you might be flying in freezing rain and quickly get above freezing when you get up there. Or at the same token, if you're descending, you may be coming out of, you know, temperatures that are well warm, just rain, and all of a sudden you're getting down into the icing layer. So again, it's something to know and be aware of when you're flying in these systems. And of course, anytime in mountains, you're pushing all that air up, very moist air mass up a slope there. You can easily cool it. A lot of times, if you were to look at the Appalachian Mountains, and that's got to be where I'm familiar with, sometimes you get a freezing rain event up on top of a ridge like Skyline Drive when you're driving down it, or the Blue Ridge Parkway there. You may have an ice storm going on there, and below that it might be above freezing. And above that, it probably is above freezing. But it just because of that air pushed up there, it cooled it off enough just at that level. And then above that, you're getting warm air advection in. So you're keeping the air above freezing, but you wind up having that icing layer right there, right around 2,000 to 3,000 feet sometimes. So going on to the next one, we'll look at instrument meteorological conditions, IFR, VFR, MVFR. Anytime a meteorologist is writing TAFs, basically what he's looking at when he's writing the TAF, he or she, is a VFR, change to MVFR, change to IFR, change to LIFR, and finally changing to whether the airport is closed or open. So we're going to look, as a meteorologist, I did it, and everyone else I ever knew did it. You're putting together a TAF that makes sense in terms of how these conditions are changing, what they did, how a pilot might see transitions. If you have a low coming towards you, for example, maybe you're transitioning from VFR, fairly high cirrus clouds, coming down to 5,000 feet, maybe down to 3,000 feet or 2,500 feet, and then you'll put another grouping right there around 2,500 feet, say. And then all of a sudden you look at it and the rain's going to be moving in. So, okay, now I'm getting some ceilings maybe down between 800 broken, we'll say. So I'm going to start putting another category. Maybe I'll start out as a scattered group or an occasional group in there, and then gradually switch over to where it's predominant. And then maybe I have some other lower ceilings I can see coming with this system as well. I may have to put another grouping in. But eventually I might see all this begin to rise up, and I'll try to indicate where you're going to go back to IFR or MVFR ceilings and how that's going to change. And the other thing, as a meteorologist, that we try to do when writing TAFs, we try to keep them short. We don't want to confuse a pilot with too much information. Sometimes we could look at a TAF, and if we went back and tried to write to what the atmospheric conditions did, you literally could write a 10, 12-line TAF. We'll typically try to keep our TAFs no more than 5 or 6, maybe 7 lines long at most. Now remember, you have ASOS and AWOS out there that are doing most of the measurements at the airports nowadays. And sometimes there's large airports that you can actually get more than one ASOS at. I know of at least several that have 2 to 3 ASOSs at them. And when they make their observation that's reported from the airport, they take the worst case scenario of all those observations, what'll bring them the worst conditions. And that's what's reported as the conditions at that airport. Sometimes you might have different conditions at one end of the runway, and the remainder of the runway may be totally another condition. I know in Charleston, West Virginia, for example, that fog comes up out of the Canal Valley. It'll form at the end of the one runways out there where the river valleys are, and might, obstruct the vision out there and be fairly low. But the rest of that runway might be, 8, 9, 10-mile visibility. But it's just that small sector that's coming up out of the valley sometimes that you can get very low visibility. And if that's not indicated in the TAFs or somehow conveyed to the pilots through ASOS or whatever, that it could be a problem. We've talked about a lot about fog and radiation fog, advection fog. I'm not going to go into much here, but you can see there's all kind of patterns that develops from and moves across the country. Sometimes you can see fog coming in off the Gulf of Mexico in to the Gulf Coast states, and you'll just watch it move up into the Midwest, or you might see it come in off the Atlantic Ocean, or sometimes you can definitely see it form out over the Pacific, come up to the Sierras and try to find a way into the valley region. And every once in a while it gets deep enough and you just see it roll down into the valleys and cover like Sacramento and those areas with fog. Weather depiction charts are a great way to see where the ceilings and visibilities. You can look at visible satellite, you can look at infrared satellite and kind of get an idea where fog might be forming. But giving these weather depiction charts will give you a lot more detail on what the ceilings are. And remember, it isn't just at the local station that you're getting this visibility and ceiling. It probably spreads out around it, and you can say, oh, there's 2,800 feet here, there's 1,300. Well, there's probably a variation somewhere between there, gradually changing over, but that's probably all overcast in that whole area. So you would just be able to know that you're just transitioning from one to the other height as with time. One of the other things about the METAR sites, most of them, there's a corporation called Gladstone Family that's actually gone out and taken pictures and satellite images and all of a whole bunch of different airports. If you enter your identifier in there, you probably get a picture of what your ASOS looks like at your airport. And looking around it, you'll get a view. It might show trees up. Maybe that blocks the wind from one direction, or maybe it'll even show you a valley that's near it or whatever. But it gives you a good local information, local terrain that you can work with to help understand, where the ASOS might be wrong that day. So one other set of conditions now, and just general hazards that were brought up in your book. And these basically go with extra things that may cause problems to aircraft. If you get hit by lightning, obviously, which is extremely rare, but it's going to cause, it may not make a very big hole in your aircraft, and probably the aircraft is still flight worthy, but it might affect your instruments. It could easily change your compass or your GPS readings. All these are something to think about. Which we got around lightning a lot. The new GO 16 spacecraft that's up there now will have a lightning data over it, and I am sure, because it's part of the Weather Service family, that data is going to be available to all pilots. It's basically going to cover the entire western hemisphere. So it'll go out over the waters a ways and cover all the United States, Canada, Mexico, down into the South America some. And these products will be available. Every 5 minutes there's going to be lightning from that. And it's not just cloud to ground lightning, which we've always recorded. It's in cloud lightning as well. So it'll give you a really good depiction of where the lightning's at, where you need to avoid what areas might have problems. Ozone, while it may not be a major issue typically, at least should be aware of it, that you're flying through a higher ozone level. And ozone doesn't do your body a whole lot of good over time. The more you're in it, the less it's healthy for you. Particularly in summertime, we get a lot of ozone alerts in some cities due to the hot weather in summer, the stagnant conditions. Uh, if you're in the upper atmosphere flying a jet, for example, you might get up into the stratosphere at times. And when you do, especially where there is really a strong upper low, and we've seen how deep down, some of the upper lows, the 200 millibar surface, may be all the way down, at 20,000 feet instead of its typical 35,000 feet where it's under because of that cold dome that it creates there. When that happens, if you're trying at 35,000, you're well up in the stratosphere, so you may be at the actual ozone level. And then there's the volcanic ash that's out there. These are always volcanoes are going to be erupting all around the world at times, and if you're flying near one, there's a lot of debris and stuff that goes out, a lot of ash. The ash will diminish rapidly, but remember, some of it's going to stay up in the stratosphere, especially when it gets up there, and it's not going to come out real fast, so it's kind of good to avoid those areas. And of course, space weather. That's where solar storms can impact, again, your GPS, maybe your communications and all. And there's a really good space weather center that in Boulder, Colorado, that actually has conditions related to aviation and how that might be impacted. And of course, on a runway, you want to know about hydroplaning from heavy rains or snow and ice, reducing your braking. And if you're working on an aircraft in a real cold climate, you want to know about the frostbite potential from wind chills. And even, the temperatures around getting down below -20, you might get ice fog that forms. And cities like Fairbanks and all get a lot of that. So we'll move on now to doing a pilot briefing here. So let's start today. We're going to go from Oklahoma City to Kansas City on up to Minneapolis. And we're going to be dealing with a low right along that route right here. A couple of them actually, one over Kansas and Nebraska, another one up over Minneapolis. There's a warm front just to the south of there, stretching eastward, and then a cold front, stationary front, another cold front back into this area. So if you go back a little bit, you can actually see how how the lows have moved with time, and the actual fronts come down through Minneapolis now, and they're on the north side of it. So we'll move on now to some satellites. So if we're going to look at this, we'll say we'll fly from Oklahoma City, Kansas City, and then on up to Minneapolis all this afternoon. So we know that we got this kind of front, warm air ahead of it. You're typically going to be thinking of thunderstorms here. On the north side of this front, probably some IFR conditions, lower ceilings. So we've got lots of issues to deal with here, probably some turbulence, maybe have some jets along this route as well. So let's think about flying at about 13,000 feet altitude. So we got a satellite image. We'll start with the IR real quickly here. I'm going to loop through it for 24 hours. Moisture coming up there. There's a whole batch of thunderstorms from yesterday. And you can see them right now. There's just a few starting to form in northwestern part of Missouri, possibly along your route. Well, at least not. You won't have to worry about it until you get to Kansas City, probably, if you left now. But just to your north at that time. Looking at visible at the same time. So let's take a look there. Now, remember, at nighttime, you're not getting a whole lot of visibles, but here comes the sun here in a second, and we'll see some more coming up. There we go. And you can see there's your Q starting up. Lower clouds, lots of moisture coming up out of the Gulf into Texas, Louisiana, southern part of Arkansas. And you can also see the low to the north up over Minnesota. Low clouds there with that. If you look at the infrared, you can kind of infer a couple things here. There's probably some kind of jet max that went out here causing those thunderstorms. Maybe there's another one that kind of kinks right in here. You may have a little bit of a trough kind of coming across to help those storms right now. And definitely have some kind of low, mid-level low up here as well. And several of them up over Canada. So you can see a lot of information here real quickly. Good strong jet, very dry. Stratospheric air coming in here, pushing in across here. So let's look at convection wise. Well, gee, they are talking about it, aren't they? With a slight risk right here. So we'll have to worry about that a little bit when we get up there, what timing that might be. One of the nice things that the Storm Prediction Center does do, it tries to predict outlooks. So thunderstorm outlooks are when the potential for thunderstorms is there. So if you were to take right now at 20 to 0Z, just north of your route, and 0Z being out there, being about 6 o'clock in the evening, you have a 40% chance of thunderstorms over a good part of where you're going to be flying across here. But then you start noticing that they're kind of slipping down to Kansas City, later, and still not quite as far to the west, so maybe going westward might be best. We'll have to take a look at that. Of course, later on, they really diminish off, except they really develop. Look how much stronger, 70% chance of thunderstorms across that area now. So it's really looking like they're expecting that squall line to grow, but not till late tonight, really. It looks like in the late tonight. There'll be some definite potential early. So let's take another look at some upper air charts here. We'll take it up at the jet stream first. And you can see it's a pretty strong jet coming in on the west coast, pushing through. And then there's the current right here of that jet. You actually have a closed low. You can really see it up over northwestern Canada there. And a kind of a ridge over the eastern part of the United States. Left a little trough down here over the Gulf Coast states coming through. If you look a little bit more detail, let's take a look at back to 500 millibars. What you'll see is everything's out of the southwest. So if you're looking at wind shear here, you're probably not going to find a whole lot until you get up towards Minnesota on the other side of that cold front. There you're probably going to have a shift in winds from aloft. The winds will be from the southwest, and at the surface they'll probably be from the northwest. So you might have some down there to worry about. Otherwise than that, wind shear is not much of an issue as far as the direction. Definitely, and not really that strong of winds here at 500, 20, 25 knots, 45 knots. So the stronger winds will be the further north you get. Again, if you look at that for wind shear as far as severe weather goes, you're really not talking a whole lot until you get up towards Iowa, in that area, at least at this time. So you want to look also, maybe see about a little moisture coming up. So let's take a look at 850 millibars. And you can see a lot of moisture coming up out of the Gulf of Mexico here, streaming northward along this frontal boundary on the east side. It's pretty dry, relatively cool air on the west side here. So we'll have to see how all this can plan to play out. One other thing we could take a look at, always kind of nice to see if soundings or whatever. Let's take a look and see if they have any soundings along our route. I'm here. So where would be a good sounding spot today at 12Z? We'll take, this is down at Norman, Oklahoma. You can see it's fairly warm here. If it did warm up a lot, you would have pretty unstable air, as there is some moisture in the mid levels, but there's not a lot of moisture at the low levels. Let's take a look at Kansas City. Kansas City, again, really warm at 850 area. So it has potential, if you can get the sunshine, to really warm, up into well in the 80s down in there, but fairly dry most of the way up. It would be unstable because the sounding does cool off some aloft, as you can see. If I lifted this dry adiabatically, I would be over here and coming up. Wind shear wise, have a little bit down here at the surface, right above 850, right below 850 millibars. There's that Midwest jet going strong, 55 knots there. So if you were flying into Kansas City, you're going to have to be aware that that'll be diminishing during the day today, but it is something to be conscious of, that you might have some wind there. Finally, looking up towards Minneapolis, very moist, very humid, probably not that stable as such, because it probably is mixed in this whole area. A little bit of wind, northwest winds, which become, at the surface, more northwest winds there, but southwest aloft. So not much there. Going below zero here, you're probably getting, if you're going to get any icing, you're going to be up probably about 10,000 feet or so. There could be some icing that start to developing in that area. Up a little ways there, minus 10s right here at almost 500 millibars. So there is a layer there where you'll have to be conscious of when you get up into Minnesota and going towards that front, that you might have to deal with some icing. So let's take a look quickly at the models here a little bit. First, let's just see what the forecast is going. We've looked at this. If you do a 12-hour forecast, and this is valid at tonight at be 6 o'clock in the evening out there, you see they got a low now to the east of Minnesota. Cold front stretching down across Iowa and down into northwestern corner of Oklahoma. 12 hours later, that cold front's pushed well out of there, pushed further south, and down into this area as well. So with that, here's some models. Let's take a look and see what the convection is going to be doing. We'll take a look at a high-res simulated convection, central U.S., and we'll do a simulated radar composite. Just to see, I want to see the timing and how thick, how big of an area those thunderstorms are going to be going over tonight. If I want to have to deal with them going north, I want to know if there's going to be, might be some holes in them I can fly through, or whether it's going to be pretty continuous. So right now, you can kind of see a circulation here in Iowa moving across. But you see how this line's just starting to form right here? Really, there's the first real indications of thunderstorms going. And they're at about 2Z, 1Z, somewhere in there. So if you figure 0Z out there is about 6 o'clock in the evening. So between 6 and 7 is when this line of thunderstorms is really going to start taking off. Might want to move it an hour earlier, 5 o'clock. So the earlier you can get yourself going northward, the better you're going to be. So the earlier you leave from Oklahoma to get to Kansas City, and then Kansas City on up to Minneapolis, the better you're going to be. It doesn't look like much in the way of thunderstorms once you get north of Iowa into Minnesota. Matter of fact, there's not even much in the way of rain up there most of the flight. But definitely something, at least from this model's perspective. Now let's take a look at another model, a different forecast model. Sometimes it's nice to have a couple opinions to see what they're doing. We'll look at the NAM model, high-res, which is just another high-res forecast model that can do its thing. Simulated radar composites for this afternoon. And we'll just do a couple, 48 hours worth of the loop here. So let's see how it does. All right, there's this, a little bit. There's the convection, really starting around 0 to 01Z, but there's a lot of holes in it initially. So you might be able to fly through, and then it gets pretty solid and goes further south with time. So with that in mind, maybe I can go back to here, take a look at it again at the first, and say, oh, well, if I got up there and could leave, we'll say by 5 o'clock in the evening, there's going to be buildups, but I might be able to have some shots through and be directed through. If I got IFR and I have a good radar to work with, I probably can go through there, even though I might want to avoid, obviously. But you really see the real higher and the real stronger stuff developing later. And even the stuff that's in Minnesota looks, it's going to be bumpy through there as well. Now, these are just a couple of things to look at. You look at the aviation weather. They got some IFR conditions up north right now and all. So let's just take a look at a couple of METARs here quick. We'll take a look around Minneapolis area and just see what's going on right now. And we can see the Minneapolis right now at the observations is MVFR conditions. And winds out of the north at 5, so your front's definitely through there. If we throw all the METARs up here, we get Kansas City. You can see there's, a little bit of wind out of the south now there, 20 knots or so. So somewhere in this portion of your flight could be some issues. The advantage of going quickly to the northwest and north here might be you get across that line of potential thunderstorms before they have a chance to develop. Whereas if you hung to the east, took advantage of the wind flow more, you might be riding along where they're developing longer and have to deal with them more. So I'll also look back at the TAFs here a minute and see what the TAFs are for a couple sites along here. So if we look at Kansas City's TAF, and this was written literally just recently, you have the southwest winds at 20, gusting to 30, so you have your mechanical turbulence down low. The first vicinity of thunderstorms they have there is not till after 6, 7 o'clock in the evening. They have their first vicinity thunderstorms, and then categorical thunderstorms isn't until almost about 1 o'clock in the morning or so, or actually midnight out there. So really not saying it's going to be interesting there, but that's one area. Let's take a look at Des Moines. Des Moines has their CB early at 22Z, but by the same token, they got a lot of lower clouds maybe around up in that area, 2,500 broken and stuff, and some MVFR visibilities. But you'll notice they never do an occasional or even a tempo group of thunderstorms. They just have it in vicinity. It basically means they think there'll be some around, but they're not really expecting a solid wall of thunderstorms, a solid line to be going through. So it's something to keep in mind when you look at that TAF. And then up in Minneapolis, some showers right on through till about 6 o'clock this evening, then broken 35, and then the skies clear overnight tonight. So the other part we want to look at, let's see what other things are going on with the convection, how they timed it. There are convective segments out right now in this area here. So you would want to think about that if you're flying up there. And you can see this brings the area of thunderstorms and stuff. Higher probability right in this area from 18 to 0Z today. And let's look at the other forecasts for turbulence, for example, along this route. We can get your turbulence forecast. We'll go down here, click on a more detailed forecast. We'll give it a flight medium. Oh, let's do a flight elevation. Bring it down towards 13,000 feet like we've been talking about. And move forward in time here. And it really looks like, a lot of the turbulence we're going to be dealing with will be just across Iowa there. So if you can find a way through that area of thunderstorms potential there. And again, it depends on how well you know yourself as a pilot. And that's going to be the biggest key to all this. And the icing for the final part here, you take a look at it. And you'll notice right there, right now, there's some icing up around Minneapolis. There's your icing in the thunderstorms. But to the northwest of Minneapolis, there's still, some clouds coming across there. It might, if you had to come in from the northwest side of Minneapolis, you might have to deal with some potential at a layer there. And we'll probably just take a look at and see if that layer is right around where you might be coming in at. Not really. Probably higher up than that, but yeah. kind of nice to be able to circle through the different layers and all. The final thing I wanted to hit was just a little bit on guidance. Every model has biases, and forecasters try to take them out or try to understand them. But there's statistics that are run that try to take into account how the forecast might be wrong in the models. And as part of that, they also print out a lot of information. They'll give you probability of precip in the 6 hours blocks, for example, probability in the 24-hour block, the amount of precip, probability of thunderstorms in here. And finally, ceilings. And they divide it up into 8 categories, with 1 being right down around 200 feet and 8 being about 20,000 feet up. And you really don't get into the IFR ceilings until you're down below about 4 or 5 and then going down. But you can see you're getting, you got some ceilings that across there. In Kansas City right now, visibility looks good. So let's say you look up at Minnesota, at Minneapolis. This is actually Milwaukee a little bit further east, but it's not. And you can still see some lower clouds and a little bit of low clouds there. So just some things to think about in your flight. I didn't talk a lot about the really the spread that the models might give, and that is something we could have looked at today to see if the models had a lot of difference on when these thunderstorms and how much thunderstorms they're going to have. But even just looking at 2 models, they look pretty similar. Their timing was pretty close, so it looks like it'll be a pretty good forecast there. So if you have any questions this week, let me know. I hope this gives you some ideas as far as when you do your pilot briefing to me in exercise 17. I want to know why. That's really what I'm looking for in that whole thing. Why you are using certain charts, why you're deciding on making your decisions about your flight based on that. So let me know if you have any questions.